This video is for Chemistry 105, Lab 7, which is for titrations. So I'll just briefly go over the introduction and then get started. Titration is the general name for a series of analytical chemistry techniques in which a solution of known concentration, which is called the titrant, is slowly added to the second solution, which is called the analyte. During addition of the titrant, the analyte is monitored. The purpose of the titration is to determine some property of the analyte, such as its concentration, purity, or molar mass. In some cases, titrations can be used to identify an unknown analyte. The titration in this lab is the simplest form of the technique. The titrant is a strong base, sodium hydroxide, of known concentration, and the analytes are acids hydrochloric and sulfuric acid of unknown concentrations. The goal of the titration is to determine the concentration of each of these acids. The titration is performed until the endpoint is reached. For the titration between an acid and a base, the endpoint is when just enough base has been added to the analyte to neutralize the acid. In order to monitor when the endpoint occurs, a few drops of indicator is added to the analyte. The indicator used in this lab is phenolphthalein. Because phenolphthalein turns from colorless to bright pink near pH 8.2, the first stable sign of color in the analyte is taken as the point at which the analyte is neutral. There are more complex forms of titration. Titrations that utilize redox reactions rather than acid-base reactions, titrations in which continuous monitoring of some property of the analyte is performed as the titrant is added, and titrations designed to test the purity of the analyte. So now we'll just briefly go over some safety precautions. You must wear safety goggles during this procedure. Sodium hydroxide is especially damaging to the cornea. Lower the burette when you need to fill it. Do not fill the burette with sodium hydroxide above your eye level. And wash your hands immediately if you come into contact with any of the acids or bases. Be careful when handling the burettes, they're especially fragile. Do not pour anything down the sink. Your instructor will collect and neutralize all of your solutions. Before you begin the procedure, think about how many decimal places there should be in measurements made with the burette and pipette. Also remind each other about the significant figure rule used for subtraction. You will lose points if your significant figures are incorrect. So when we look at the burette, we notice that these are in mils, and then there's tenths for all the way from 0 to 50. And then for the 10 mil pipette, is the same thing. It shows mils, and then there's tenths of mils from 0 to 10. So now we'll want to set up our burette on a ring stand, and then we can get started on step 1. Alright, so we have our ring stand, and we'll just put our burette in the ring stand. So first I'm going to go put on some gloves. Then you'll also want to put on your goggles. Now we're ready to begin. Step 1 is place approximately 100 mils of 0.100 molar sodium hydroxide into a beaker to use at your bench. So we'll want to grab our 250 ml beaker and just fill it to 100 mils of the 0.100 molar sodium hydroxide. So all of our solutions and materials are at the instructor bench, and so we'll want to grab the 0.100 molar sodium hydroxide. So I'll just pour out 100 mils. And then put it back at the instructor bench. And then What we'll want to do, since all of the solutions that we're using today are clear liquids, they'll all look the same. So we'll want to mark this as our 0.100 molar sodium hydroxide. So we just take our China marker out of our student bench. And it's kind of hard to see, but I can tell this is our sodium hydroxide. And then it says, wash and drain the burette with water and then with approximately 10 mils of sodium hydroxide. So what we'll want to do is get a waste container. So we'll grab our 400 ml beaker from our student bench and just write waste on this one. And then we're also going to want to grab DI water. So at the student bench, you'll also have a squirt bottle of deionized water. Alright, so now we'll want to wash and drain the burette with water and then approximately 10 mils of sodium hydroxide. So we'll just open this up, and I'm gonna keep this in the closed position, or this is the open position, this is the closed position. Put our waste container underneath, and I'm gonna use a funnel and just put it into my burette at eye level and just fill this with the DI water. And then we're going to let it drain into the waste container. So that rinses our burette, and we'll want to wait until all of the water has gone through, and then we can add our sodium hydroxide. Alright, so our burette has been rinsed with deionized water, so now we will add approximately 10 mils of the sodium hydroxide and let that go through the burette into our waste container. And to do this, we'll want to put it about at the 40 mark, and we want it to be in the closed position. We'll take it down so that we can fill it at eye level. And so our burette is a bit above the 40. So now we'll let this drain through to rinse the burette with the sodium hydroxide. And this is important so that you know that you're not diluting the sodium hydroxide that you add from any water that might be sticking to the inside of the burette. Alright, so now we'll close the stopcock again.